So the next and the fourth theorem that we have to talk about is sum or difference theorem. So if the function is of the type, there are two functions, f of x and g of x, and two functions having a relation of summation or having a relation of addition with each other. So how to find the derivative of such functions? So by the theorem, the rate of change of such functions with respect to x is equal to it will apply it individually in order to find the derivative or the rate of change. So this is the statement of the theorem about the addition, about the addition or subtraction, because they have the same method of finding the derivative. I'm just solving with the addition sign in between the two functions. So if there is not addition sign, there is a subtraction sign in between the two functions, then the method doesn't change, method will be the same. Now we will have to prove it. So prove it by using the definition of derivative. So proving this theorem by using the definition, firstly we have to write the function, that is f of x plus g of x. The second is to add a small change, that is delta x. So f of x plus delta x plus g of x plus delta x. Then subtracting them, and so I have to write x here, it's more suitable. F of x minus g of x. By subtracting these two, we get this expression. Then now I will write this with this and then these two. So f of x plus delta x minus f of x. So plus g of x plus delta x minus g of x. Now the next step is dividing both sides by the change, here as well here. Now we should apply the limit. So applying limit on both sides. So we will get limit delta x equals to 0. By the laws of limit, we know that limit should be applied in this and this individually. So skipping this step, I've just written this and limit on this factor gx plus delta x minus g of x over delta x. So by the definition, we know that this is d by dx of the function f of x, by definition we know that, and this is d by dx of the function g of x, that is the rate of change of the function f with respect to x and the rate of change of the function g with respect to x. So finally we proved this addition or subtraction theorem, because this is the way we have to prove it, by using the first principle or by definition. Now moving toward example, take a function y 5 to the power 5x to the power minus 2, then x 7/2 plus 9. So by applying the theorem of addition, we can find the rate of change of the individual factor here, this, then to this, then to the next. Now this is just same of the third theorem of a constant multiplied by a function. So 5, then d by dx of x to the power minus 2 plus, this is, we can apply the power rule here, 7/2 comes down, there should be a decrease in the value, then the rate of change of the function x, and this is 9, and 9 is a constant, so rate of change of 9 is equal to 0. So 5, we should apply the power rule here, minus 2 comes down, there should be a decrease in the value, then dx by x dx, and 7/2 x 7/2 minus 1, we get 5/2. So it is minus 10, x minus 2 at minus 1, we get minus 3 plus 7/2, x 5/2 plus 0, and this is the required answer of this function. This is the rate of change dy by dx with respect to that rate of change of y with respect to x. So we will talk about the next theorem in the next video, so stay tuned. Goodbye.